The idea in part D, which is part E of this PDF that I'm looking at, is that we want to insert dummy nodes such that for every pair of nodes in our graph, the difference in their travel time is exactly 1. Okay, so this is basically implementing BFS in a little bit differently, in a different way, and we'll see how we can do this. So the whole idea is that we can actually physically quantify and visualize the gap between travel times between two nodes that are actually in our graph here, using however many dummy nodes the gap is numerically well, the gap between the travel time is numerically. So if, for example, if San is 122 travel time and SFO is 125, then their gap is going to be 3, right? And so we're going to have two nodes. So this is going to have a gap of 1, this is going to have a gap of 1, this is going to have a gap of 1. And so we're able to physically visualize and also quantify how much difference two nodes have in their travel time. And so again, this is really an implementation of BFS. So we start with a fringe, which is going to be a queue, right? And a data structure that has queue-like properties is a linked list. We first add the root. And as long as the fringe is not empty, we do this procedure of first removing whatever's at the beginning of your fringe, of your queue, okay? And as long as its name is not null, we want to print out its name. We want to print it out with a space. This is just like an aesthetics issue, just because we want to have it print out like this, right? Okay, and then for all of its children, okay, if child.travel time minus its current travel time, the current node's travel time is greater than 1, then we make these dummy nodes, right? So right now we haven't made any dummy nodes, and now we're basically inserting dummy nodes if the differences in travel time is greater than 1. And so if it is, then you're going to create a new station, null. So let me go back to the constructor for a station. The station takes in a string name and an int travel time, right? So the name is going to be null. That's why we're checking if name is not equal to null and then printing out the name. So we're only printing out names of actual nodes that are in our graph, not dummy nodes, which is why with dummy nodes we pass in null as our name, and so we have to check if name is null or not. And then travel time is going to be the current node plus 1, current travel time plus 1. Okay, and then we dummy.children.add child. So basically we're making this connection, right? We're making SFO be the child of this null node, okay? And then we're adding to the fringe the dummy, okay? Otherwise, if the difference is less than or equal to 1, then we just add the child. So in the case where it's greater than 1, we need to add a dummy before adding the child. In the case where it's not greater than 1, then we can just directly add the child. Okay? And so that is it for this question. And just to clarify how this code is able to actually create multiple dummy nodes instead of just one, is that after you create this dummy node, you're adding that dummy to the end of your queue, right? And so your queue would look something like this, where you have different nodes, right? Potentially different nodes. And then you have your dummy node here. And by the time you get to your dummy node and you pop this off the fringe, right? Your dummy node is going to have its travel time so the child of this dummy node is going to be the child of the original node, right? So for example, here, let's say that San Bruno is our cur, okay? And so its child is SFO originally before we added a dummy node. And so now it looks like this, right? We don't have this extra dummy node, we just have one dummy node and its child is SFO. When we get to this dummy node, what happens is we see that its time, which is 123, and its child's 125 has a difference greater than 1, right? So in that case, we go into this code as before, and we create a new dummy node that will allow us to break down this increment of 2 into 2 one-sized intervals. And so basically this is how we're able to create more than 1 dummy nodes.